I'm Professor Aileen McGonigal from the University of Queensland, presenting on behalf of all co-authors. Our article is entitled Artificial Intelligence-Based Face Transformation in Patient Seizure Videos for Privacy Protection, and it's published in the Mayo Clinic Proceedings Digital Health. So the background of this work is that sharing medical videos is a common need in the clinical setting. Epileptic seizures can be captured on video, often with simultaneous electroencephalography, for precise diagnosis, classification, and brain localization. Increasingly, video recording of seizures is done not only in the hospital setting, but also in the home, including smartphone capture. This brings new challenges for how we manage video material. For complex clinical cases, experts from different centres often need to confer using video material. Besides clinical diagnostic use, seizure videos are also a key source material for epilepsy teaching, training and research, including deep learning approaches requiring large video datasets and collaboration with non-clinical researchers. However, sharing seizure videos poses a problem of patient privacy, especially in the context of increasing use of online medical activities. Our objective in this study was to investigate the feasibility and accuracy of AI methods of facial de-identification in hospital-recorded epileptic seizure videos for improved patient privacy protection while preserving clinically important features of seizure semiology, that is, the clinical expression of seizures, which may often involve involuntary facial changes that provide us with important clinical clues to seizure type. So the balance between these two somewhat opposing attributes of preservation of semiology and yet de-identification is key to clinical usefulness in our field. We took videos of patients with epileptic seizures displaying seizure-related involuntary facial changes from a series of recordings performed at Taipei Veterans General Hospital and selected a single representative video frame per seizure. We then tested 3 AI facial transformation models, the first morphing the original image with a different male face, the second substituting with a female face, and the third was a cartoonization approach. And we then performed scoring by 5 independent expert clinicians according to the preservation of semiology and the de-identification, and we also measured these features using objective computational analysis. These are examples of the 3 AI transformation models with the original patient's face from a video clip of a seizure on the left, and then you can see morphing with a different male face, substitution with a female face, and cartoonization. This graph shows the clinicians' average scores. The vertical axis shows preservation of clinical features, and the horizontal axis shows degree of de-identification. The different AI models are represented by colours. Blue is cartoonization, red is female face substitution, and yellow is morphing with a male face. The results show that highest de-identification scores were reached with the male morphing AI model, the yellow cross furthest to the right. However, the best compromise between de-identification and preservation of clinically relevant features was the cartoonization model, shown by the blue cross at the top. So to conclude, artificial intelligence-based face transformation of medical seizure videos is feasible and may be useful for patient privacy protection. In our study, the cartoonization approach provided the best compromise between de-identification and preservation of clinically useful features. This approach could mitigate privacy concerns when sharing clinical video data for expert review, teaching and research. And next steps would be to test a wider variety of models in larger datasets using dynamic video rather than still frames as we did here, and testing effects of different facial variables such as age, gender and ethnic background. Many thanks for your attention.